Hello everybody, welcome to at NEET Physics by Arun video channel. In today's video, we are going to solve a multiple choice question, solve an MCQ in the chapter Dual Nature of Radiation and Matter. Dual Nature of Radiation and Matter. What is the question, sir? Let us look into the question. Protons of wavelength lambda are incident on a metal. Okay? The most energetic electrons ejected from the metal. Most energetic electrons means what? Kinetic energy of the electrons ejected by the metal surface are the maximum. Ke max. Okay, that's it. So ejected from the metal are bent into a circular arc of radius capital R by a perpendicular magnetic field having magnitude B capital B. Now you are asked to find the work function of the metal. The work function of the metal is, you are given four options. Hc by lambda minus Me. What is Me? Mass of electron. Plus E square plus B square plus R square by 2 Me. What is E? Charge of electron. What is B? Magnitude of the magnetic field or radius of the circular path, and M mass of it. So H Planck's constant, C velocity of light or speed of light, lambda is the wavelength of the incident. So this is option 1. Similarly, this is option 2. Hc by lambda plus 2 Me into EBR divided by 2 Me the whole square. So the significance of the symbols that I have already explained. So option C is Hc by lambda minus Me C square minus C square B square R square by 2. And option D is Hc by lambda minus 2 Me into EBR divided by 2 Me the whole square. Okay, which is the right answer, sir. So option is very much lengthy. The question is also, the sum is also somewhat lengthy. Okay, so by photoelectric equation, you know that H nu is equal to capital H nu is the energy of the photon. H nu is equal to Hc. Instead of nu, you can also write C by lambda. Hc by lambda, that is equal to phi plus K max. What is phi? The metal, the work function of the metal. This is phi. And Ke max is the energy of the most energetic electrons. So this Hc by lambda is the energy of the photon, and phi is the work function of the metal. So you keep phi here and Ke max other side. So phi is equal to Hc by lambda minus Ke max. Remember, this is the work function of the metal. Phi is equal to Hc by lambda minus Ke max. So in all the options, Hc by lambda is here and minus is here. Okay, that's all. And let us find the solution. Okay, so fine. Then how to proceed further, sir? Okay. To find Ke max Hc by lambda minus the potential. So the ejected electrons are bent into a circular arc by a magnetic field, perpendicular magnetic field. So you have studied cyclotron and all such things. So you know the circular path of a particle, charged particle, which is under a magnetic field, perpendicular magnetic field. So radius of the circular path is equal to MV by BQ. MV means mass of electron, B velocity of the electron, B magnetic field, Q is the charge of electron. Sir, he is the charge of electron. Okay, come to that also. So MeV divided by BQ. Therefore, V is equal to V BQR divided by so BQR divided by A. Already told you that instead of Q, you can use the symbol E. E is the charge of electron. V is equal to BR by ME. Mass of ME is the mass of the electron, or ME is the mass of the electron, E is the velocity of the electron, B is the magnetic field, Q or E, எல்லாமே charge of electron. Both are charge of electron. Okay, that's it. Now Ke max is equal to half E V mass of electron, B velocity, half intensity. Now you know the value of V, velocity of electron, V is equal to VER by M. So we get Ke max is equal to half into Me into, unit of V, VER by ME, square, no? Square. VER by ME square. Now, multiplying the numerator and the denominator of RHS, not the LHS, only RHS. Multiplying and the numerator and denominator. When you multiply the same factor by the numerator and the denominator, the value will not change, the denominator. By 4 we get. So, Ke max is equal to 4 into 1 by 4 into 1 by 4. Why this is 1 by 4, sir? We are multiplying the denominator also. This is 1 by into 2, this 2, 1 by 2, the 4 multiply denominator. ME, BER by ME, double. Double in 4 into 1 by 4 into 1 by 2, 4 extra. Okay, that's all. Now Ke max is equal to, இங்கே ஒரு 2 இருக்கு, இங்கே 4 இருக்கு, இங்கே 1 2 2 2 4. So 2 into 1 by 4 பண்ணது 2 எடுத்தாச்சு, ஏன்னா அதை அடிச்சிட்டோம். So 1 by 4 into ME into BER by ME, the whole square. So Ke max is equal to 2 into 1 by 4 into 2 அடிச்சு அப்படியே வெளியிருக்கோம்ல, 1 by 4 ME into BER by ME, the whole square. So Ke max is equal to 2 into, you put this 4 inside the square, then what will happen? 4 will become 2. உள்ள 2 இருந்தா தான் வெளியே வரும்போது 4 இல்லையா? So 2 squares. If it is 2 here, when it comes outside the square, it will become 4. So 2 into ME into BER by ME, BER by 2ME. When this 4 goes inside the square, it will become 2, because 2 squares is 4. So we have nothing. Okay. So now we have found the value of Ke max. What is the equation for the work function of the metal? Phi is equal to hc by lambda minus Ke max. Okay, that's all. So Ke max is equal to 2ME into BER divided by 2. So substituting this in equation 1. What is equation 1? Phi is equal to hc by lambda minus Ke max. So instead of Ke max minus 2ME into BER by 2ME the whole square. So of the 4 options, D is the right answer. Answer D out of 4 answers given in your question. Answer D, option D is the right answer. So far, we have seen at about 7 multiple choice questions in this chapter, dual nature of radiation and matter. So in our next video, we will see a question from electronics and communication chapter. We have already in our channel have seen 2 multiple choice questions in that chapter, electronics and communication. We will see 5 more questions in the coming videos from that chapter. Okay. Till then, thank you one and all.